Okay, good evening, everyone. My name is William and I'm big as your leader mathematics. Today, I'm pleased to present our food technology simulation project title is Coconut Thermal Pasteurization Engines. This is the was developed for the food engineering and preservation to optimizing of premium pandan coconut product using harmonious kinetic modeling. Okay, the summary of the chosen bioscience problems. The bioscience problem we are addressing is the perceptions of the volatile pandan in coconut during pasteurization. The signature sense of this coconut comes from a highly volatile compound called is 2-acetyl and 1-pyrrolines. The industrial challenge is the standard thermal sterilization, when necessary for safety, often triggers thermal cracking, which destroys this delicate aroma, leading to a significant loss in product quality and market value. Okay, the importance of studying this problem. Studying this problem is crucial because it allows us to find critical balance between microbiological safety and organic quality retention. We must meet the stringent 5 log pathogens reduction limits to eliminate bacterial like E. coli. But we do so without causing thermal burnout. By calculating the activation energy, we can mathematically identify the ideal high temperature short times segments that maximize aroma while ensuring the product is 100% safe for consumption. Now I would like to explain meaning of each point. Point number one, thermal destruction calculus. Our system uses a exponential descent model f and x to predict remaining r. The first derivative is beta as the instantaneous velocity. A high negative value here indicates that aroma is being destroyed rapidly at the specific seconds. And point number two is real-time monitoring and stage for degradation. In our simulation, if a product is held for too long, for example 36 in inter stage for at this point aroma retention dropped to a mere 27.1%. And point number three, the golden HT window. Data analysis confirmed the golden window for processing is between 55 degrees Celsius to until 95 degrees Celsius for only 10 to 50 seconds. This specific window satisfies the 5 log safety requirement while maintaining a high premium aroma retention level of 55 seconds to 85 seconds. The last is recommend one way to make this HTML better. To improve the HTML interface of this tool, I recommend implementing an interactive sweet spot overlay on the kinetic graph. By adding a highlighted zone where the safety curve is 5 log and the quality curve is 80 second retention intersect. Operator could identify the perfect processing time visually and instantly without needing to manually interpret complex calculus data. Okay, guys, this for me.
I will presenting a short explanation of how calculus can be used to understand sugar accumulation in harmonious mangoes. This project connect both bioscience and mathematics, showing how real biological process can be modeled using equation that help prediction and decision making. As mangoes grow, they, sh- their sugar content increase over time. Farmer want to know the best day to harvest so the fruit reach ideal sweetness. However, the sugar dose do not increase at a constant rate. Instead, it follow a pattern that like slow at the beginning and fast in the middle and slow again near the end. This natural pattern is why we use a logistic grow model, which is commonly used in biology. For the mathematic model, the logistic growth function is used is this fx. This model, each part represents something biological, like where L is a 16.5 matrix, the maximum sugar level in bricks. For K, 0.25 grow is the growth rate. And for 75 is midpoint day where sugar rise faster. And this function describe how the sugar level increase over days of the fruit development. To know when the sugar increase the faster, we use the derivative written as fx. The derivative tell us the rate of change or how quickly sugar is being added each day. For logistic curve, the sugar accumulation rate is highest at the midpoint, which in this model in day 75. This means the mango is ripening most rapidly at this time, and farmer can use that information to plan harvest schedule. By combining biology and mathematics, we can make better decision in agriculture using this model. Farmer can estimate the best harvest window, reaches reaches can compare different mango varieties. Student can see how calculus has real application in bioscience. This show how mathematics tool can help us understand living system more accurately. For lastly, this project demonstrates how a logistic function and its derivatives can model sugar accumulation in harmonious mangoes. Through calculus, we can identify when the fruit is developing sweetness most rapidly, helping improve agricultural planning and improving fruit quality. Improving fruit quality. Thank you.
Okay, good afternoon, everyone. So today I want to talk about one of the most famous in our Malaysia, that is durian musang king. So especially this durian is culture D197. What is D197? So D represent the Department of Agriculture. That is new durian clones with D categorized. And for 197, the fruit is shows that register number in recorded in 1993. As an agro-product student, we face a unique post-average challenge with this fruit. Unlike other post-average challenge in this fruit, other fruit plucked from the tree. Premium Musa King durians are only harvested after a natural mature drop. The moment the durian hit the ground, a biological clock starts ticking. The durian experiences a sudden surface in breathing, which we call a climacterical respiration surface. This surface activates an enzyme called alpha amylase. This enzyme is highly active in enzymatic hydrolysis, which is just a fancy way of saying it rapidly break down the fruit's tasteless, insoluble starch and convert them into sweet, soluble, reducing sugar. We measure this sweetness level in a unit called degree Brix. Let me explain what is degree Brix. A degree Brix is a unit of measurement used to quantify the amount of dissolved solid, primarily sugar, in a liquid. 1 degree Brix equals 1 gram of churros per 100 gram of solution, which translates to 1%. If we want to export premium fresh durian to global market, we must find the absolute peak of sweetness and texture. To determine this by using calculus, especially the first derivative fx, we can calculate the exact speed of durian accumulation day by day. Finding this exact milestone allows us to time our food processing perfectly. If we catch the durian fruit at the absolute peak, we can apply nutrient freezing at 196 Celsius. This freezing immediately alters the durian metabolic look in the premium custard texture and trap in sulfur compound that give Musang King in famous aroma. Let me take you through our interaction HTML simulation model, which track the durian over a 7 days post-average period. As we adjust the timeline slider, the durian progress through 4 distinct biochemical phase. So the first one, to track this progress, our lab uses empirically mathematical model to represent the sugar accumulation. So let's see the problem. This is the problem. We need to find the total sugar function. Fx equals to d over dx, and the function was negative d1x power 3 plus 0.9x power 2 plus 2x plus 10. So if we calculate this one, we can get the final answer is negative 0.3x power 2 plus 1.8x plus 2. To find the speed, we just need to use simple power rule method that I say just now. When we click, so in our graph, when we click at 0, this is the way you can see. The 0 represent the day the durian dropped from the tree. So if we go to 3, it's almost higher. It's peak higher because we hit the climacterical peak. As we just proven mathematically, this is the point of maximum speed where sugar are accumulating incredibly fast. This is our golden window. So this time we can pick in our international export. So in this time we can export our durians to other country. In pastry optimatical eating challenge in day 4, next the could reach the very top of the hill. The sugar level is at day 4 is absolutely high, over 30 bricks, because the fruit has run out of such reserve of convert. The speed of new sugar concentration effects slow down almost zero. Finally, in left too long, the durian enters sense, being the decay and shells split open. So the shells split open over 5 to 6 days. That time, the durian can see it's almost the sugar level was too high. So sometimes in day 7, the durian was become in waste. So to conclude the simulation tools, I exactly use GitHub and also Gemini to represent this simulation. For me, we can use another way that shows a durian sweetness over here. So what could be interesting to see the simulation more better. That's all for me. Thank you.
Hi everyone, my name is Nurul Anissa Soleha binti Muhammad Zamri with matrix number F25A1488. So today I'll be presenting my research interface, which is about the paddy variety MR297 Precision Growth Analyzer. So this project explores the powerful integration of bioscience, agricultural management, and calculus to address a critical macroeconomic challenge in Malaysia, especially in food security sector. So let's look at the core problem here. Malaysia's national self-sufficiency level for rice currently fluctuates between 65% to 70%, meaning that we are heavily reliant on imports. So to secure our food, we must maximize the yield of paddy variety MR297, which is a predominant high-yield variety developed by MARDI. The biological problem here is that farmers typically or traditionally apply nitrogen fertilizers based on fixed calendar days. This method leads to massive nutrient runoff, environmental toxicity, and unexpected vegetative surge that actually reduce grain yield. We are studying this specific growth dynamic method. So it boils down to precision agriculture by modeling the plant's cumulative height using a logistic S-curve. We can use the first derivative fx to calculate the exact instantaneous elongation rate in centimeters per day. So finding the absolute peak of this curve, we point a vital micro window, which is the inflection point. So supplying targeted fertilizer input exactly at this physiological peak optimizes clinical branch count and spicalate formulation. So this simple calculus-driven timing shift can drive crop yields up to an impressive 8 metric tons per hectare while eliminating harmful chemical runoff. So we can see the formula here to get the inflection point and growth rate and also asymptotic height. Okay, so now let's deep dive into the growth curve and key points. So if we look at our precision analyzer interface, we can track the crop's development by adjusting the timeline slider. So here is the timeline slider. We can just slide to see the growth. So let's break down the key biological milestone. So at day 0 until 25, actually this is the seedling and early vegetative stage. We can see that 0 until 25, the growth velocity is very low, which is under 0.5 cm per day. It means that the plant is establishing its roots. Next, day 26 until 54. This is active tillering stage. We can see that growth enters an acceleration phase, ramping up from 0.5 to 2 cm per day. Now let's take a look at day 55. This is the inflection peak, or we call it as panicle initiation, which at exactly 55 days after transplanting, the plant hits its mathematical peak, which the cumulative height is 52.5 cm, and the rate of elongation reached its absolute maximum at 2.1 cm per day. We can see here at day 55, the growth velocity reached 2.1 cm per day. So, this is our golden target for premium nitrogen application. Recommendation to improve the HTML web interface. For me, I think is that the web can add a Q&A part where strangers and any who I decide to share the link can add questions asking the farmers regarding the plant. To make this interactive tool even better for researchers and agricultural extension officers, I recommend adding an interactive what-if simulation panel for fertilizer dosage. We can see right now, the HTML brilliantly visualizes the ideal timeline. By adding input fields where users can input actual nitrogen application dates and amounts, the system could overlay a simulated predicted yield curve against the optimal curve. This would give farmers a direct visual risk assessment of how a delay in fertilizing impacts their final tonnage. So to conclude my session, with precision tools like this, we can bridge the gap between calculus and field management to secure Malaysia's agricultural future. Thank you, and that's all from me.